Physics Part 436 Communication Satellites. Long distance communication using radio wave is possible on medium wave band, as surface waves, and the short wave bands as sky waves. However, for modern communication system, there are three major disadvantages. Number one, long distance communication using sky waves is unreliable in that it depends on reflection from layers of ions in the upper atmosphere. These layers of ions vary in height and density, giving rise to the variable quality of signal. Surface waves are also unreliable because there is poor reception in hilly areas. Number two, disadvantage number two. These wave bands available on medium waves and short waves are already crowded. Disadvantage number three. These bandwidths that are available are narrow and consequently unable to carry large amounts of information. Satellite communication enables more wave bands to be made available at much higher frequencies, thus giving rise to much greater data carrying capacity. The basic principles of satellite communication is shown in the figure. A carrier wave of frequency f up is sent from the transmitter T on Earth to a satellite. The satellite receives the greatly attenuated signal. The signal is amplified and carrier frequency is changed to a lower value of f down. The carrier wave is then directed back to the receiver R on Earth. The carrier wave frequency f up and f down are different so that the very low power signal received from Earth is not swamped by and can be distinguished from the high power signals that is transmitted back to Earth. Values of uplink frequency f up and the downlink frequency f down might be 6 GHz and 4 GHz respectively. The 6.4 GHz band, other bands are 1311 GHz and 3020 GHz. The communication satellite may be geostationary orbit. In this case, the satellite orbits the Earth with a period of 24 hours at a height of 3.6 into 10 raised to 4 km above the Earth's surface. The satellite orbits in the same direction as the rotation of the Earth from west to east, and the orbit is above the equator. From the viewpoint of a person on Earth, the satellite remains above the same point on Earth's surface. The transmitting aerial and receiving aerial on Earth both have large parabolic reflectors. One advantage of the geostationary satellite is that these aerials can be fixed in position since the satellite does not have to be tracked. A geostationary satellite can have a permanent link with a transmitting ground station. Communication is maintained with any point on Earth's surface that can receive the signal from a satellite. A number of satellites with overlapping areas such that any area can receive signals from one of the satellites allows for long distance communication. This removes the need for long distance submarine cables. International television broadcasting is possible, allowing live events in one country to be viewed in another. While the geostationary satellites are equatorial orbits, which means that communication in polar regions may not be possible because a satellite will not be in line of sight. A further problem results from the height of the orbit. Between the transmission and the receipt of the signal, the wave must travel at least twice the distance between the satellite and Earth. and that is 7.2 into 10 power raised to 4 kilometer.